S. Muthukumar from Department of Mathematics, K.S.Rangasamy College of Technology. In this lecture video, I am going to explain about the construction of an analytic function. This method was developed by Milne Thomson. There are two formulas available to construct the analytic function. If the real part is given, then the corresponding analytic function is evaluated by using the formula f of z equal to integral of ux of z comma 0 minus I into uy of z comma 0 dz. In case the imaginary part v is given, the same formula is modified by using the conditions of analytic function. The condition for analytic function is ux equal to vy and uy equal to minus vx. In the first formula, we can replace these two values, ux by vy and uy by vx. Therefore, f of z becomes integral of uy of z comma 0 plus minus into minus plus I into vx of z comma 0. Now see the problem. Find the analytic function f of z equal to u plus iv if u equal to e power x into x cos y minus y sin y. Here the real part is given, so we have to use the first formula. For that we need the value of ux of z comma 0 and uy of z comma 0. The given function is rewritten as e power x into x cos y minus e power x into y sin y. Now differentiate this with respect to x, ux of x comma y equivalent to, there are two x functions. Here we have to apply u into v formula for differentiating this term. For that, here differentiation of u, that means e power x differentiation into v value, e power x differentiation e power x into x value into cos y. While differentiating with respect to x, cos y is constant, plus this term is second one u into, now differentiate v term, that means x term differentiation 1 into cos y, and also the third term is e power x into, that is y into sin y. Now substitute x value as z and y value as 0 in the above differentiation term. So e power z into z cos 0 plus e power z into cos 0, here y equal to 0. So the entire term is 0. The reduced form is e power z into z plus e power z, since cos z 0 equal to 1. Now differentiate the given function 1 with respect to y, dou u by dou y. Now apply the uv formula to the second term, y into sin y. In the first term, e power x into x constant, cos y differentiation is minus sin y, minus e power x into, use uv here, 1 into sin y plus y into cos y. Here the substitution for x is z and y is 0. So after replacing these values, uy of z comma 0 becomes 0. Therefore the analytic function f of z equal to ux of z comma 0 minus I into uy of z comma 0 dz, since the given function is u. Now replace the derivative values here. Ux of z comma 0 equal to e power z plus e power z, and the second one is 0. Now separate the integral here. Integral of e power z into z dz plus e power z into dz. Here use u into dv formula for the first integral. The u dv expansion is z into e power z minus e power z. Here there is only one term, so e power z integration is e power z plus one constant. Here we can cancel these two terms, plus e power z minus e power z. Therefore, the required analytic function is z into e power z plus c. Now see the second problem. Find the analytic function f of z if u plus v equal to x minus y into x square plus 4xy plus y square. Here the given function is combination of u and v. So we cannot calculate this f of z function directly. For that we have to use some concepts here. That means f of z equal to u plus iv. Multiply the equation number 1 by I. So I into f of z equal to I into u minus because of I into I square value equal to minus 1. So the second term is minus v. Now we add these two equations 1 and 2. So f of z into 1 plus I equivalent to u minus v plus I into u plus v. Now assume that the left side term is equivalent to capital F of z and the real part u minus v is equivalent to capital U, and the imaginary part u plus v equal to capital V. So this capital F of z is an analytic function of another analytic function. Here the imaginary part v is equivalent to the given function u plus v. So now we can find the capital F of z analytic function, since the imaginary part is given. Therefore assume that the given function is equivalent to imaginary part of a new analytic function capital F of z. V of x comma y equal to x minus y into x square plus 4xy plus y square. Now differentiate this function capital V with respect to x and y, and then replace the values for x and y. For the first time differentiation with respect to x, there are two x terms. So apply u into v formula for both derivatives. The differentiation is given here. For the first case, u differentiation with respect to x 1 minus 0 into v value plus u into v dash. V differentiation with respect to x 2x plus 4x into 1, then the last term is 0. Now replace x by z and y by 0. So after replacing these values, v of x comma z equal z comma 0 equal to 3z square. Now differentiate the capital V function with respect to y. Again apply the u into v formula here. Here differentiation with respect to y. So in the u differentiation, x is 0 and y becomes minus 1. This is v term. Here u into v dash. This x square plus 4xy plus y square differentiation with respect to y. Then substitution for x and z. X for z and y for 0. So its resultant form 3z square. Both the functions are equivalent to 3z square. Now we are calculating the entire problem for the imaginary part function. Therefore, its corresponding analytic function formula is capital F of z equal to Vy of z comma 0 plus I into Vx of z comma 0 dz. Substitute its derivative values here. 3z square plus I into 3z square. Now integrate with respect to z. Z square integration is z cube divided by 3. Here take the z cube as a common one. So z cube into 1 plus I plus c. So we have calculated the new analytic function capital F of z. But the required analytic function is small f of z. So use the relationship between capital F and small f. That means capital F of z equal to 1 plus I into small f of z. From that we can get the value of small f of z. F of z equal to z cube plus c1. That means divide the entire equation, this equation, by 1 plus I. So the constant term becomes constant by 1 plus I, that is again constant c1. This is the required analytic function for the given function. Thank you.